I want to factor 3x minus 6, I'm always going to start factoring these by looking for the common factors of the terms. So I need to think about what are the terms. And the terms here are going to be 3x and negative 6. So if I think about 3x and negative 6, 3x is 3 times x. And negative 6 doesn't have an x in it, but negative 6 is divisible by 3. So if I divide each of these by 3, I get 3 over 3 times x, 1x. And negative 6 divided by 3 is negative 2. So if I want to factor, what I'm doing is I'm rewriting 3x minus 6 in a way that looks different but means the same. So it's like going by different names in different groups, or doing your hair differently on a different day. You're still the same person, but maybe you look a little different. So I'm going to take this 3 that was common, I pull it out in front, I'm undistributing it, so I need to bring in my multiplication parentheses. 3 times x makes the 3x that I started with. And 3 times negative 2 makes that negative 6 that I started with. So if I were to go back and, for example, distribute that, so I can check if I'm undistributing, if I'm factoring and undistributing, I can check it by multiplying or distributing. 3 times x gives me 3x. 3 times negative 2 gives me negative 6. So I have successfully factored this. If you want to see this in terms of the algebra tiles, so what we can do here is let's set up our 3x minus 6, our 3x's. There we go. 1, 2, 3 x's, and 6 negative 1's. 1, 2, 3, 4, 5, 5, 6. And then the task of undistributing or factoring these is essentially making a rectangle. We want to fill a perfect rectangle. Oh goodness, I only wanted 3 of those x's. There we go. I want to fill a perfect rectangle with these exact algebra tiles. These exact tiles. So what I can see here is that my tiles, my rectangle, my full rectangle, right, here's my full rectangle, is 3 tall, 1x, and a negative 2 wide. So 3 times x minus 2 gives me 3 x's and negative 6.